Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about optical detectors. So what is the need for optical detectors? So in optical communication where we use optical fibers for transmission of data, so we use optical detectors at the receiver side. So it is used to detect the optical signal received from the fibers, and it converts the light signal into electrical signal to process the output. So these are semiconductor diodes, which is the part of optical receivers. So it detect the light signal, which is photons, and convert it into electrical signal. So optical detectors are used in various applications like automotive, safety and analytical equipments, communication, astronomy and industry. So these photodetectors have various types like photodiodes and like pin photodiode, avalanche photodiode, and also photomultiplier tubes, etc. So we are going to see the pin photodiode and avalanche photodiode in detail. So first of all, we can see the picture of pin photodiode, which is consisting of three layers: p-type semiconductor, n-type semiconductor, and intrinsic region. So when light signal is detected by the pin photodiode, so it creates the current through the external circuit. So it happens through the mechanisms such as, so when the light signal photons are absorbed in the intrinsic region, so which is the reverse biased pin photodiode. So from this, electron hole pairs are generated within the material, and from this the current is generated in the external circuit. And we can see in this diagram where p-type and n-type material are separated by a depletion layer. So when light signal photons are striking upon the material, so here in the intrinsic region, electron and hole pairs are generated. So this is the working of pin photodiode. So when photons strike the pin photodiode, it excites the electrons, so that it creates the electron hole pairs. So when the reverse biased PN junction can create the electron hole pairs, it results in the photocurrent. So this photocurrent is converted into an electrical signal by amplifying that, and then we can get the output from the receiver circuit. Next we can see the avalanche photodiode. It is the photodetector which provides high gain. So it consists of four layers: n-type, p-type, and then intrinsic region, and then again p-type layer. So this region, where I region is the intrinsic region and p region is heavily doped. So it provides avalanche multiplication, which provides high gain, and also it increases the receiver sensitivity. So in this, carrier multiplication occurs, in which higher photocurrent is generated, so which provides the very high sensitivity in the receiver circuit. And working of avalanche photodiode, here avalanche breakdown occurs in the photodiode when it is given with a maximum reverse voltage. So when the light incident in the p-type layer in the p plus region, so here electron hole pairs are generated, which are multiplied using the avalanche breakdown mechanism. So in which the charge carriers collide through the other atoms and produce the high number of electron hole pairs. So this results in the high photocurrent. So we can see, list the characteristics of this avalanche photodiode. So it provides high sensitivity. So it means we can detect the very weak optical signals from the fiber, and also it provides the high gain. So because of the avalanche process, and it produces a high signal to noise ratio compared to pin photodiodes, and also it offers a wide bandwidth, and these are the advantages. So avalanche photodiodes produces increase in sensitivity for the very low light signal, and also it provides high gain, but they have some difficulties due to the complex structure like fabrication difficulties, and also it requires high biasing voltage. So let's take the assessment for this topic. So depletion region must be which of the following to allow the large fraction of the incident light to be absorbed in the device. So the answer is option A, that is thick depletion region. So thank you for listening this lecture.